Good afternoon, friends. I am Jigar Ratnottar, working as a lecturer in Atma Institute of Technology and Science for Diploma Studies. Today we are going to learn something about the fundamental concepts of electrical energy. So let's start towards the journey of electrical energy. Friends, as we all know, the surrounding us, we can find out the energy in many ways, like mechanical energy, the chemical energy, heat energy, electrical energy, solar energy. Lots of energy we can find out surrounding us. But among that all energy, we see that the electrical energy is the most useful energy form which is surrounding us. There are lots of the reasons behind it. Some of the reasons are the electrical energy can be easily transmitted through the wires, so we can easily transmit it through the long distance. It can be stored, it can be large amount of production can be also possible with using the electrical energy. Also, the easily transfer to one form energy to the another form of energy. That's why the surrounding us, the electrical energy is the most useful energy. So just starting with the electrical energy. As we all know that according to the energy conservation law, the energy cannot be created nor be destroyed. It only be transmitted or transferred from one part of the energy to the another part of the energy. So to get the electrical energy, we require some sources or the devices which directly converted or which gives us the electrical energy from the another form of the energy. Some of the source of electrical energy are example here, like a battery, which directly give us the electrical energy from the chemical energy, where the two electrodes, one is the positive, one is the negative, make some procedure, and due to that procedure we can easily get the electric energy through the chemical energy. Another example of the getting the electrical energy, that is the generator, which directly converted the mechanical energy into the electrical energy. Another example is the windmill, that directly gave us the electrical energy from the wind energy. Then also we know the photocells, which directly give us the electrical energy from the light energy. So these are some of the sources of or the devices of the electrical energy. Now let's move towards the electrical parameters, which are also important in today's topic. The electrical charge, electrical current, the voltage, that is also known as the potential difference, and the electrical resistance. We just start with the electrical charge. What is an electrical charge? So for that we just take one example. When the rod of ebonite is rubbed with any clothes or any material, then exactly what happens? Whenever we are rub the ebonite rod and keep it towards the clothes, woolen clothes, or some leaves or some papers, then due to the friction, some of the energy can be generated at one of the end of the ebonite rod. So the leaves, the papers are attracted toward that rod. So this is nothing but it is known as a electric charge. Electric charge is a property of the tiny particles in an atom. The quantity of charge should always be identified with a positive or the negative sign. So any of the material has either the positive electric charge or the negative electric charge. And we can also find out some of the materials has electrically neutral. It means they have equal amount of the a positive electric charge and the negative electric charge. Here we saw one example, we saw one figure which has the electron, proton and the neutron. As per the figure, we can see that the electron has the negative sign. It means electron has the negative electric charge. The proton has the positive sign. It means the proton has the positive electric charge. And the neutron has the zero, that is null. It means neutron has nothing electric charge, or it has a zero electric charge. Now this is the structure of an atom. You can see that the core part of the any material, there is one here is one example of the atom. There is a core part contains the protons and the neutrons, and surrounding that atom there are the electrons. Electrons are orbitally revolved. Now just move towards the electric current. How anyone should know about the electric circuit, electric current? So current is nothing but the actual substance that is flowing through the wires of the circuits. These are the electrons. Just see the example. You can see the river. What exactly the substance in the river? That is flow. This is the water. So exactly water is the main substance in the river. So same here, if we take about the electrical circuit, then the wires, into the wires the electrons are flowing. So the flow of electrons is nothing but the current. See the definition of the current. This is the movement of electric charge through a substance. Now the current is also known as a unit of the current is the ampere, and according to the definition of the current, that I equals to Q upon T. Q is nothing but the electrical charge that is measured in coulomb, and it has the unit that is Q. So the per second the number of electric charge is more, we can say that the number of more the current is flowing in the circuit. Let's see one animation video. Here one circuit, and this is the all about basic about the electricity. So here you can see that the one battery and surrounding us all the materials which is made with the protons, centrally contains the protons and the neutrons, and the electrons are orbitally revolved. See, all the atoms has the two main charge, the positive and the negative. As per the figure, we can see that the positive are repelled, negative are same polarity charge, so they are repelled with each other, but the positive and negative charge carriers are attract with each other. Some of the materials surrounding us has the figure such like that. The neutrally the electron protons are positioned, but the electrons are drift like a metal. So if we take one example, just keep one wire that contains some atoms and one electrons. So here is the example. So if we allow the some experiences of force, then what happens? The first atom has the energy and electrons now jump toward the second atom, same second to third to fourth. So it is just like a conga light. Friends, as we all know that the jumping the electrons with the tiny distance, but the overall effect has the speed of the light. So that is nothing but the flow of electrons, and that is we call as an electric current. Now move toward the electrical voltage or the potential difference. How exactly we should thinking about the voltage? It actually the force that pushes the current through the electrical circuit. In this picture, that is the force waters that can be forcefully downward. Voltage is also known as the potential difference. What is the potential? Potential is the energy. So if we talk about we think about any electrical circuit, so to overall movement about the electric current in a circuit, that is nothing but the one point to the another point, that is nothing but the potential difference, and that is a voltage. So it is the difference between 2 points in an electrical circuit. So it is potential difference, it is the effect due to the flow of electric current. Actually, if we want to brief overview about the potential difference, then we just go through the waterfall analogy. Here there is one dam. The dam contains the upper part has the higher potential energy, and the lower part has the lower potential energy. So now if we allow the motor, then what happens? The forcefully waters come down to the lower part. So the potential across the upper part has the higher potential energy with respect to lower. So this is the 2 points, A point and the B point. So potential is definitely difference between the A point and the B point. So this is nothing but the potential difference, and same thing happen in the electrical circuit. Now the electrical resistance. What actually the resistance is? It actually the friction. It is the property to oppose something. See, there is one picture. There is a river. What exactly the flowing in the river? That is a water. Now if you consider there is nothing stones or the rocks in the path of the river, then what happens? The flow of water can be smoothly flowing through the river. But actually what happens when you are putting these some rocks and some stones? Definitely the flow of water will be blocks, or it will be fluctuated. So the rocks and the stones has the property to oppose the flow of water. Same thing happened in electrical circuit. See, there is one picture. Here what happens? The bottom part of the bottle, if we make it the narrow, it means it offers the very high resistance. Then what happens? If the resistance is very high, then the flow of electrons definitely fluctuate, definitely block. So the flow of electrons will be decreased, and the flow of electrons is nothing but the current. So if the resistance is very high, the flow of current is decreased, and ultimately the current will be decreased. The figure B, where the resistance is very low, it means the part of the bottom part of the bottle is broader than the figure A. It means the resistance is very low. That means electrons can easily move further that portion. So it means the flow of electrons is high. That means the current is definitely high. So resistance is actually the measure how the difficult it is the current to flow through the electric circuit. The total amount of electrical resistance in a circuit, that is determined by the amount of current in the circuit for a given voltage. So whenever you are applying the voltage to the electrical circuit, the number of electrons flowing in the circuit, that is the electric current, and it depends upon directly the resistance in the circuit. The more the resistance circuit, the less the current that flows. Here is one just example. The figure A, which contains the one bulb, that the one bulb is offered as a looks like a one resistor. So what happens? Single resistance, it means the flow of current is high. That means the intensity of the bulb is also very high. You can see that. But if in the figure B, whenever we are putting another one bulb to the path of the circuit current, then what happens? The resistance becomes twice. It means the current always divided into two bulbs. So the intensity of the bulb will be decreased as per the figure. Now we again put the another bulb to the path of the circuit. Then what happens? Definitely the resistance becomes the thrice. So the current is now also decreased. So according to that figure, we can say that if we increasing the resistance, the value of the resistor, then the property of the flow of electrons definitely blocks, and ultimately the value of current is also decreased. The resistance of a material is a measure of how easily a charge can be flowed through it. So resistor defines how actually the current will be flow in the circuit. Resistance is also nothing but the how much the push is required to get the current to flow in the circuit. The unit of the resistance is sigma, that is ohm. It's a Greek letter, and we can say that the R equals to V by I. So if we take the current is a 1 ampere, then the 1 voltage required to passing the current through the circuit, then the value of the resistance is 1 ohm. Every circuit component has a resistor. So the device which offers the resistance is known as a resistor. Here some of the pictures of the resistors. You can see that the different color codes are also there. This is the symbol of the resistor. If you want to draw any circuit and you want to add some resistor, then you have to use that symbol. Resistor is also used to control the flow of electrons. The electrical components called the resistor can be used to control the current. A resistor has generally the resistor can be measured with the two methods. The first one is the traditional method. The second one is with using the multimeter, where you can directly measure the resistance. Just we go through the traditional method, which is shown here. There is one table which has the color code and respected that the numbers. like black, brown, red, orange, yellow, green, blue, violet, grey and white. So respected color has the number 0, 1, 2 up to 9. So here one just example, there is one resistor which has the numbers like that: red, first number is the red, second one is a green, third one is the orange and the last one is a silver. So as per the traditional method, the first and the second number are indicated as a digit, the third one is work as a or used as a multiplier, and the fourth one is the tolerance or the accuracy. If the color is the silver, then the tolerance will be plus or minus 10%. If it is a gold, then it is a plus or minus 5%. And it's a brown, then it's a plus or minus 1%. So according to that table and that example, we can say that the red has the value that is 2, green has the value 5. So the first digit is the 2, second is a 5, so it means the 25. Then the third one is a multiplier is the orange has the number that is the 3, so it is 10 raised to 3, that is 1000. So 25 into 1000, that means a 25 kilo ohm resistor. So the value of that resistance we can easily find out, that 25 kilo ohm. With the silver, acceptance of the silver has the accuracy that is plus or minus 10%. So it means that that resistor has the value of 25 kilo ohm with plus or minus 10% tolerance. This is the second method which we can easily use to measure the resistance. George Simon Ohm, which is a very well known scientist, which gives the very useful equation into the field of electricity that gives the relation between the current, voltage and the resistance. According to the Ohm's law, if we know about any two quantities, then we can easily find out the third quantities. So according to that, if we know about the voltage and the resistance, then we can find out the current, like I equals to V upon R. If we know about the value of the current and resistance, then we can find out the value of voltage, that is V equals to I into R. And if we know the value of the voltage and the current, then we can easily find out the resistance, that is R equals to V by I. So this is the very important equation in the field of electricity. Now just here is one example to calculate the